Welcome to 6WIND's vRouter webinar, where we will present our secure vRouter solutions for service providers. My name is Kelly LeBlanc. I run 6WIND's marketing program and am based in Santa Clara, California. Joining me is Jan Rappaport, 6WIND's VP of Product Management. Jan will introduce our VPN Concentrator vRouter solution in detail, including a demo. We will conclude with a Q&A. Please use the Q&A button at the bottom of your screen to submit your questions, and we will answer them in the order that they are received. First, let me start with a quick introduction of 6WIND. 6WIND is a software company headquartered in France with offices around the world, including Santa Clara, California, and Beijing, China. We make high-performance networking software with deep expertise in telecom. In recognition of our innovation, we received an investment from Cisco and a vRouter Innovators Award from IDC. For those of you from the developers community, you may know us as the founders of dpdk.org and a top contributor. Here's an overview of our software product portfolio. Our initial flagship product, 6WIND Gate, is a complete Layer 2 through Layer 4 networking stack available in source code form factor, optimized for standard commercial off-the-shelf servers including x86 and ARM architectures. 6WIND Gate is integrated by OEM vendors to develop a complete networking appliance, solution, or system. 6WIND Gate is used to build 6WIND's vRouter software solutions. 6WIND Virtual Accelerator is a vRouter that fulfills all the requirements to power the hypervisor with the necessary features for virtual networking infrastructure used in network function virtualization infrastructure, data center virtualization, or network appliance virtualization use cases. 6WIND Turbo Router, Turbo IPsec, and Turbo CGNAT are vRouters in the form of software appliances that lead the market with a performance advantage. Popular use cases include border routers, IPsec VPN gateways and concentrators, security for mobile infrastructure, carrier-grade NAT, and more. Here is a list of some of our key customers, many of which are brand names in the networking and applications market. OEMs such as Cisco, Nokia, NEC, Mavenir, Nuage, and many others have been using our 6WIND Gate source code to build their own products for over a decade. Service providers and enterprises such as Arbor Networks, AT&T, and OVH use our vRouters to build their networks and services. In today's webinar, we will start with an overview of our secure vRouter solutions based on our Turbo IPsec software appliances, followed by a VPN Concentrator software demo. At the end, we have plenty of time for Q&A. Let's begin with the product introduction of 6WIND Turbo IPsec. 6WIND Turbo IPsec is a vRouter that is beating legacy security equipment in service provider markets thanks to our innovation. The competition is intense right now, and as we are competing against large incumbent networking companies and focused security hardware vendors. We've been influencing these customers to think differently with our price performance value proposition and a new way of solving mainstream security problems. This new way of thinking is thanks to our high performance software for commercial off-the-shelf servers. Our first secure vRouter use case, deployed through Turbo IPsec, is a VPN Concentrator vRouter, which Jan will detail in his demo. AT&T is the largest Tier 1 service provider in the US and uses 6WIND's vRouter as a VPN concentrator for its enterprise VPN service called VVIG, or Virtual VPN Internet Gateway. Our Turbo IPsec vRouter is used to aggregate the IPsec traffic from enterprise users. As a result of using our Turbo IPsec on commercial off-the-shelf servers, AT&T was able to reduce direct CapEx by 70% and support IPsec clients of all types and thousands of IPsec tunnels. Our second secure vRouter use case, deployed through Turbo IPsec, is a site-to-site IPsec VPN vRouter. IPsec VPN solutions are critical networking infrastructure used to create secure, high-speed communication tunnels between trusted endpoints across the Internet. Examples include site-to-site VPNs for secure connectivity between data centers and between remote sites for corporate networks. Proprietary hardware gateways were historically required to solve high-performance IPsec VPN challenges with well-known downsides, including vendor lock-in and very high equipment costs. There is a market need for cost-effective alternatives to avoid a cost versus security trade-off. 6WIND solves this challenge with software. Our third secure vRouter use case, deployed through Turbo IPsec, is a mobile infrastructure security vRouter. In the anatomy of the 4G and 5G infrastructure, the mobile backhaul network is an IP network that connects eNode Bs to the Evolved Packet Core, or EPC, and carries user, control, and management data. Securing the mobile backhaul is the task of a high-performance IPsec VPN appliance called the Security Gateway. Deployed at the EPC location, security gateways have the important task of aggregating and terminating the IPsec VPNs carrying traffic with eNode Bs. Again, proprietary hardware gateways were historically required to solve high-performance mobile infrastructure security problems, with the associated vendor lock-in and very high equipment costs. 6WIND delivers a cost-effective alternative with software. Now let's look at 6WIND Turbo IPsec's features. 6WIND Turbo IPsec can be deployed in bare metal and virtual machine configurations. Its features include IPv4, IPv6 networking with support for VRFs, BGP OSPF dynamic routing, tunneling, NAT, PPPoE and L2TP client server, ACLs, GRE, VLAN, VXLAN encapsulations, LAG, high availability, and more. IPsec VPN functionality is available through IPsec and IKE features for secure VPN tunnels and connections between sites, data centers, or mobile infrastructure. 6WIND's IPsec VPN performance is impressive, and this is one of the reasons we've won so many use case awards. On an Intel Xeon E5 processor, we benchmarked 12 gigabits per second of throughput per core, up to 100,000 IPsec tunnels, and 1,000 tunnels per second, all in software. And performance scales linearly with the number of cores. Combining VRF, IP and IP, and filtering to create IPsec VPN tunnels, we deliver 7 gigabits per second per core. And for customers who are now leveraging Intel's new Xeon Scalable processor family, you can see we increased performance by 50% on the new Intel Xeon Platinum processors. Here we can deliver 18 gigabits per second per core and 10.5 gigabits per second per secure VPN tunnel. It is the same 6WIND software that gives you a 50% performance increase on the latest generation processors. 6WIND's vRouter allows you to build a range of solutions on commercial off-the-shelf servers with the same software. We support a range of powerful Intel CPUs from the Atom processor all the way up to the latest Xeon Scalable processors and 1 to 100 gig NICs. Many of you already have servers from one of these leading vendors, so you are ready to go. Just download our software and you can have a router with 1 to 100 gigs of throughput performance according to your requirements. If you are purchasing servers for your deployment, you have a wide range of options and flexibility for bare metal and virtual machine deployments. We license our software with 1 gig to 100 gig options. Now for deployment options. Here we see 6WIND's vRouter deployed bare metal on commercial off-the-shelf servers or within virtual machines. Within virtual machines, there are 3 options with varying levels of performance. The first is on top of standard open source hypervisor infrastructure using Open vSwitch or Linux Bridge with hypervisor options including Linux KVM, VMware ESXi, and Amazon Web Services. The second leverages hypervisor bypass technologies such as SRIOV or PCI pass-through, which dedicate hardware resources to virtual machines for the highest performance, but loses some of the benefits of virtualization such as live migration. The third runs on top of GWIND's virtual accelerator vRouter in the Linux KVM hypervisor domain for the best virtual performance with zero hardware dependence. Performance is close to bare metal, and virtualization features are preserved. We give you these different deployment options so you can make incremental software upgrades for your cloud transition. Remember, it's the same GWIND software for bare metal or virtual deployments. GWIND vRouter provides both traditional CLI-based management and IT-style management based on automation and integration with high-level orchestration tools. For this, GWIND proposes a Yang-based netconf API. Configuration can happen through the CLI and netconf API for integration with third-party management tools and orchestrators. Our data models leverage Yang and are therefore easily understandable and extensible. For deployment, we provide package images for bare metal, KVM, VMware, and AWS, and leverage the Linux Cloud Init features that enable the customization of day one configuration at startup, including initial networking configuration, default users, custom software packages, and configuration files. Finally, for monitoring, we support the traditional SNMP and syslog mechanisms, plus telemetry through SFlow, and graphical analytics with time series database. We have pre-integrated the vRouter with InfluxDB and Grafana, which are standard open source time series database and analytics software. Our integration and default Grafana dashboards are available on GitHub for the community to download and extend. Now let's walk through some examples of real-world cost savings when comparing GWIND's Turbo IPsec vRouters on commercial off-the-shelf servers versus hardware IPsec gateways. Let's do the math. We need to prove the fact that cost savings with vRouters are worthwhile. Day one costs for a GWIND Turbo IPsec perpetual license on a commercial off-the-shelf server saves customers over 50% versus hardware competitors. GWIND's Turbo IPsec's cost per gigabit per second of IPsec traffic is roughly $1,000, which is a very attractive price. When calculating total cost of ownership over 5 years, we save customers up to 80%. We welcome you to try this exercise for yourself. This concludes my introduction of the GWIND Turbo IPsec vRouter solution, and I will now turn it over to Jan for our VPN Concentrator vRouter demo.
Thank you, Kelly. This is our demo platform with the VPN Concentrator sitting at the edge of the enterprise headquarters. Remote workers and enterprise subsidiary sites open IPsec tunnels towards the VPN Concentrator for a secure connection to the enterprise resources. The VPN Concentrator is composed of 2 Turbo IPsec instances working in high availability mode, with VRP for redundancy and IKHA for seamless failover, thanks to the continuous synchronization of IPsec security policies and associations. The cluster is monitored using the Grafana visualization tool. We run each vRouter instance on 5 cores, 10 threads of a dual-socket platform equipped with Intel Xeon Platinum 8170 CPUs running at 2.10 GHz. Each instance is allocated 8 GB of RAM. We use an Ixia XM2 traffic generator to inject traffic at high rate, and we emulate up to 10K remote IPsec connections thanks to StrongSwan's load tester tool running on a separate platform. Let's start our demo by reviewing the VPN concentrator configuration using the CLI on the first VPN concentrator called VPN C1. Using the showconfig command, we start by reviewing system information. We see the host name vpnc1.vpnc.6wind.com and the dimensioning of the vRouter's high-performance packet processing engine called the FastPath. We see that 2 NICs and 4 cores 8 threads are assigned to the FastPath for this test. Then we can dump the interfaces. This shows a management interface, one interface to the LAN, one interface to the WAN, one interface for high availability synchronization, and the VRP's interfaces used for redundancy. With this configuration, we will be able to demonstrate up to 10 gigabit per second of traffic in both directions, or in other words, 20 gigabit per second of IPsec processing. Now, let's check the routing configuration. In this case, it is very simple, with static routes configured to send clear flows towards the IXIA. Next comes the IPsec configuration itself. We can see the general options, tuning the capacity of the IPsec stack. We can see the VPN configured with security policies for the IXIA for throughput and with the load tester tool for tunnel establishment, as well as the pre-shared key used to authenticate IK exchanges. The configuration of this VPN relies on templates that define the parameters of the IKE phase 1 and phase 2 negotiations, including Diffie-Hellman group, encryption and authentication algorithms, rekey time, replay window size, and more. In this test, we use AES GCM with a key size of 128 bits for the IPsec ESP encryption. We can check the equivalent configuration in XML format on the second VPN concentrator used for high availability. This is what a netconf client would send to the vRouter to configure it in a programmatic way. We see the same information, including routes, interfaces, IKE templates, VPN and security policies, etc. Back on VPN C1, let's check the status of the interfaces. We see that the IP addresses are properly configured, including the VRP interfaces, meaning that VPN C1 is the master for the high availability cluster. Let's now switch to the IXIA traffic generator. This is the IX network UI, where we can see the different flows. There are 8 flows configured in each direction using two 10 gig ports. The throughput indicated by the IXIA gauges is for clear traffic. When encapsulated with IPsec, the packet size and therefore the throughput increase. With the algorithms used in this demo, 20 gigabit per second of IPsec traffic correspond to 18.9 gigabit per second of clear traffic throughput. Let's start the traffic. We see that 18.906 gigabit per second of clear traffic can be processed without any packet loss, which means that we achieve 20 gigabit per second of IPsec processing. While the traffic is running, we can dump the packets on VPN C1 to verify that they are encrypted using ESP. Let's now have a look at the key performance indicators in the CLI. These KPIs include product information such as license and version, system information such as CPU or memory usage, networking statistics, and others. These are streamed from the vRouter to an InfluxDB time series database and then displayed in the Grafana Analytics dashboard to better analyze the dynamics of the system. In the dashboard for VPN C1, we see the status of the system, including CPU usage in Linux and in the vRouter's fastpath. We see that we reach the link capacity for the WAN interface when IPsec packets flow. And a bit down the screen, the IPsec SA and SP graphs reflect the 16 security policies and associations used to protect the IXIA traffic. Scrolling through the dashboard, we can also see process usage, user count, and disk usage. Let's now check the IPsec state in detail using the CLI. We can dump all IKE VPNs to review their status and the corresponding peers' IP addresses and fully qualified domain names. The total number of VPNs can also be displayed. When needed, we can filter the output on a specific peer for debug purposes. The detailed output includes the states of the security associations, the local and remote endpoints, the lifetime of the security associations, statistics in bytes and packets, and more. Finally, the show log command allows to review the sequence of IKE events, and it can be filtered out for a specific peer. Let's now demonstrate tunnel establishment rate. Our screen is split between the CLI on VPN C1 on the top and the load tester command line on the bottom. Load tester is a tool from the StrongSwan open source project that can simulate the connections of IPsec clients at high rate. The VPN count on VPN C1 is 8 when we start the load tester tool. As connections start establishing, we can see the VPN count increase on VPN C1. In Grafana, the IPsec Security Association and Security Policy graphs show us the IPsec connections being established until 20K SAs and SPs are reached, which corresponds to our objective of 10K IPsec tunnels. We see on the graph that the XR traffic is still going through at wire speed. So we have just demonstrated that we can maximize the capacity of a full duplex 10 gigabit per second link with IPsec traffic, while establishing up to 10K tunnels. Let's now check high availability. This is another Grafana dashboard where we see a high-level status of the redundant instances of the VPN Concentrator. Both are active and in good shape. We can see from the FastPath CPU usage graph that VPN C1 is the active instance processing the IPsec traffic. FastPath CPUs are inactive on VPN C2, but we will see that the IKE sessions are synchronized and VPN C2 is ready to take over traffic in case VPN C1 fails. Our screen is split between CLI consoles on VPN C1 on the left and VPN C2 on the right. The VRP configuration and state show that VPN C1 is the VRP master and VPN C2 is the backup. The VRP interfaces on VPN C1 bear the virtual IP addresses of the cluster, while there are no IP addresses on the VRP interfaces on VPN C2. Now that we have reviewed link redundancy, let's check IKE sessions. The high availability configuration shows the group, the synchronization interface, and the peers addresses that are used to continuously synchronize the IKE sessions between the active and inactive systems. We see the 10K plus 8 IKE VPNs configured on both sides. These have been synchronized on VPN C2 while they were established using load tester on VPN C1. We will now trigger an activity switch by setting down the interface connected to the LAN interface of VPN C1. This will cause VRP to change states and VPN C2 to take over traffic. We can see from the CLI that VPN C1 is now backup and VPN C2 has become master. The virtual IPs of the VRP cluster are now configured on VPN-C2 for both LAN and WAN interfaces. Back to the Grafana overview dashboard, VPN-C2's FastPass CPUs are now loaded, indicating that IPsec processing has been taken over. On the other hand, FastPass CPU usage on VPN-C1 is 0. Looking at the detailed dashboard on VPN-C1, it is now clear that traffic is not being processed as the throughput of the interfaces is 0. On VPN-C2, on the other hand, the throughput is 20 gigabit per second, meaning that traffic has properly been taken over thanks to the already established VPNs when the activity switch occurred. This concludes our demo, where we have demonstrated how GWIND's vRouter can be deployed on a standard off-the-shelf server as a VPN concentrator to terminate 10K IPsec tunnels, maximizing throughput on a 10 gigabit per second link and providing redundancy and seamless failover, all this being monitored in a graphical environment. In our demo, we used 5 cores per VPN concentrator instance and 8 gigabytes of RAM, knowing that throughput scales with the number of cores and the number of tunnels scales with memory. And now I'll hand it back to Kelly for Q&A.
Thank you, Jan. That was an excellent demo. We can see there's some questions now coming in, so let's open it up to Q&A. Remember to use the Q&A button at the bottom of your screen to submit your question. Okay, the first question, what platform did you use for your demo?
So we run each vRouter instance as a VM. We use 5 cores and 10 threads of the platform. So as I said, it's a dual socket platform with Intel Xeon Platinum 8170 CPUs at 2.10 GHz. We use 10 gig NICs, Intel 82599. In this platform, we have 64 gigabytes of RAM, and we allocated 8 gigabytes to each VM. So this is the platform we used for the demo, but actually you could run the same demo on any platform, like for example, Intel C3000 for lower performance requirements, or an ARM NXP LS1046 platform that we support as well. Just remember that our data plane performance scales with the number of CPU cores, so that's for the throughput of the IPsec, and the control plane performance, the number of tunnels, scales with the system memory. So with a pure software solution like ours, you can easily build a range of solutions according to your requirements using the same software.
Okay, thank you. Next question. How do you license your VPN Concentrator vRouter?
It's simple. We license according to throughput requirements and number of tunnel requirements.
Okay, right now I see we have one more question coming in, which is great because we have about 1 minute left. So this will be the last question. What's the performance of your VPN Concentrator vRouter?
So in this demo, on the Intel Xeon Platinum CPUs, we have shown that we maximize the link. So we have demonstrated 20 gigabit per second. This was using 4 cores for the FastPass, the packet processing engine. So the vRouter instance has 5 cores, and we use 4 cores for the packet processing. And if you remember from the demo, we see the cores are loaded at around 60%, so which means we have more room for performance. So yeah, basically the performance will be dependent on the use case, because it also depends on the flows and the way you process traffic, whether it's symmetric or not. But globally, this gives you an idea. So with 4 cores, we were able to maximize our 10 gigabit per second link. And in the slides before, also we saw in a benchmark environment that we were able to demonstrate 18 gigabit per second per core on big Intel Platinum CPUs.
Okay, thank you, Jan. All right, thank you all for your questions. Our Q&A session is now over, and this concludes our webinar. If you have any additional questions, please don't hesitate to contact me directly. I'm happy to help. We look forward to hearing from you soon. Bye for now.